Let's begin by considering the surface area of a cylinder. I have a very popular cylinder here, a can of soup, and we've mostly discussed volume and surface area in this unit. While volume refers to how much soup is in the can, the surface area in this instance would refer to the amount of material needed to cover the can. So the base is going to have the aluminum material. Of course, the can itself is aluminum all the way around. And when we're thinking about our lateral area, I want you to consider that being the label in this case, so the actual soup label. Let's look at a net of a cylinder. A cylinder is going to have a top base and a bottom base. A cylinder also has a height because it's a three-dimensional shape. Now I can take this apart, and if we think of it as just peeling off the bases, and if I were to take the side apart, we would get the shape of the net of a cylinder. We have our bottom base, the height, and the top base. That is why the net of a cylinder looks like this. Now let's discuss the surface area of cylinders. Keep in mind that when I say surface area, I mean the total or sum of the areas of each face of the three-dimensional solid. So in our Campbell soup example, it's going to be the area of the top base, the bottom base, and the label. When I talk about lateral area, I'm just referring to the area of the faces of the three-dimensional solid excluding the bases. So in our Campbell soup example, this is just the label of the soup, not the top and bottom of the can. To find the total surface area, we're going to add the area of the top base plus the area of the bottom base plus the lateral area. We also know when we're talking about cylinders, the top and bottom bases are congruent circles. Congruent means exactly the same. Therefore, they will have the same area. I took apart the net earlier in the previous clip, but the net of a cylinder will look like this. The rectangle in the middle is the lateral area. When we find the area of that rectangle, it's our lateral area. The circles are the top and bottom bases. When we find the area of one circle, we know the area of the other. So the net of a cylinder is made up of two circles in one rectangle. So what do we actually need to know to find the surface area of a cylinder? We need to know that the area of a circle is found by using the formula A equals pi r squared. R stands for the radius of the circle, and we know that pi is approximately 3.14. When we find the area of the circular bases, we're halfway done. The next thing we need to know is the area of the rectangle, which will give us our lateral area. The formula for finding the area of a rectangle is its length times its width. But keep in mind, we're just going to be given a description of the prism. So we have to, of the cylinder. So we have to think a little bit about that. The width of the rectangle in the net is going to be the same as the height of the cylinder. The length of the rectangle in the net is going to be the circumference of the circular base. We find the circumference by C equals pi times the diameter, or C equals 2 times pi times the radius. When you multiply the radius in 2, that's the same thing as finding the diameter. So to sum that up, we find the lateral area of a cylinder by multiplying the circumference of the circular base by the height of the cylinder. Let's try an example now. We're given a cylinder with a radius of 6 centimeters and a height of 5 centimeters. That's all you need to know about the cylinder to figure out its surface area. So first, let's find the area of the top base. We're going to use the formula A equals pi times the radius squared. We know that we can approximate pi as 3.14. So I'm just going to write that in parentheses. Remember that when things are in parentheses and they're next to each other, that means that we're going to multiply. We said the radius is 6 centimeters, so I'm just going to substitute that in for r, and then I'm going to square that quantity. Now the order of operations tells us that we have to do our exponents before we can do the rest of our multiplication. So we're not going to do anything with pi yet, but let's go ahead and square that radius. 6 times 6 is 36. The last step to find the area of the top base is to multiply these together. So get out your calculator and do it. We'll see that the area is going to be equal to 113 400ths. Since our units are centimeters and we're talking about an area, our units are now centimeters squared. So we just found the area of the top base, and we know that the top base and the bottom base are going to have the same area. So we found the area of our two bases. The only thing that we need now is the lateral area. Remember in our last example, we said that the lateral area for a cylinder is going to be the circumference. I should write that out. Circumference times the height of the cylinder. The formula for the circumference is pi times the diameter, or 2 times pi times the radius, excuse me. If our radius is 6 centimeters, our diameter is going to be equal to the length of two radiuses put side by side. So our diameter is going to be 12 centimeters. So to find the circumference, we just multiply pi, which we said is 3.14, times 12. When we do that, we get 37.68, and our units are still centimeters. So all we multiplied was pi and 12, because 12 centimeters is the length of the diameter. To find the total lateral area, we have to multiply the circumference with the height of the original cylinder. We know the height is 5, so our lateral area is going to be equal to the circumference, which is 37 68/100ths, times 5. Both of those units are centimeters, so when we actually multiply, we're going to get 188 4/10 centimeters squared. That's just our lateral area. So now we know the area of our bases, 113.04 centimeters squared each, and our lateral area. We said to find the total surface area, we have to add those up. So 113.04 0.04 plus 113.04 plus 188.40. We've got base 1, base 2, lateral area. When we add that up, we're going to get 414.48, and our units are still centimeters squared because we're talking about area. That's going to be our surface area. The last measurement that we might need to find when talking about cylinders is the volume. For cylinders and prisms, we can use the formula volume is equal to the area of the base times the height. In the last example, when we did surface area, we found that this cylinder had a base with an area of 113 400 centimeters squared. We know the height is 5 centimeters. The volume now is very easy. We multiply 113 400 centimeters squared times 5 centimeters. When we multiply that out, use your calculator, we will get 565 2/10 centimeters cubed. Remember that volume is going to have those cubic units because we multiplied centimeters squared times regular centimeters. That's going to give us centimeters cubed. So again, to find the volume of a prism or cylinder, it's the area of the base times the height.